Hi class, in this recording we're going to focus on some homeostatic imbalances of the cardiovascular system or circulatory system. First, we're going to focus on coronary artery disease. And coronary artery disease is generally defined as anything that constricts the coronary arteries, so the blood vessels that supply blood to the tissue of the heart. Those blood vessels that are going to prevent heart attack from happening. So anything that will cause them to constrict or become the inner diameter, the lumen, to become narrower. So as we look at this inner diameter, here we have a full lumen, but then over here, the lumen's been restricted because there's been a buildup of lipids. And this buildup of lipids is called atherosclerosis. And these lipids are going to build up just under the endothelium, or within the endothelium of the blood vessel, so that the lipids are themselves not going to be directly exposed to the bloodstream. So as that endothelium bulges and it swells, it's almost like a pimple on the inside of your blood vessel, for lack of a better analogy, except instead of being filled with pus, it's filled with lipids. And as it bulges, it becomes damaged, and eventually there can be small tears that will expose the lipids to the underlying blood vessels, initiating the intrinsic clotting cascade. Now, as these, the extrinsic clotting cascade. Now, as we look at the endothelium can also be damaged by hypertension. High blood pressure, diabetes is a common source of damage to the endothelium, and there's a variety of other causes as well. Something else that will initiate the intrinsic clotting cascade, not the extrinsic, is down here. Over here, if blood is flowing this direction, on the leeward side of this plaque, or the downstream side of the plaque, there's a lot of extra turbulence right here in an area where there's lower circulation of blood, and that turbulence in the blood can initiate the intrinsic clotting cascade, whereas a small tear in the endothelium will initiate the extrinsic clotting cascade. As we look at these plaques that build up, a lot of monocytes will penetrate the walls of these damaged vessels where we have those plaques building up and transform into macrophages. And they are actively trying to remove the lipids, the cholesterol and fats that are building up. As they remove those cholesterols and fat molecules, they are transformed in what is known as a foam cell. And these foam cells can build up, and we have the mass of foam cells build up until we have an atherosclerosic plaque, or an atheroma. And once we have this atheroma buildup, the platelets are going to adhere to the damaged areas, secreting platelet-derived growth factor. They're trying to heal the damage. And as they secrete platelet-derived growth factor, we're going to have more immune cells attracted. We're going to have mitosis of muscle and fibroblast cells within the tunica media of the blood vessel. And we're going to have deposition of collagen. This bulging mass, though, is going to continue to swell up as we have additional cells growing within the mass, and it's going to continually and further obstruct the lumen, the opening within the artery. And if you don't remember, a lumen is just a generic term for the hollow space in a hollow organ. So as we have that obstruction grow, and a condition known as angina pectoris can build up. And it's pectoris. I know a lot of times I say pectoralis. I learned how to say it wrong. When we think of angina pectoris, it's pain of it's associated with the pectoral muscles. And it's intermittent chest pain. Not all angina pectoris is associated with a heart attack in process or a coronary artery disease. Sometimes angina pectoris is associated with extreme physical exertion. Usually, angina pectoris isn't going to become a factor unless we have 75% or more of the lumen obstructed by that plaque that's built up. As the plaque or atheroma builds up, it's going to have immune cells build up within it to stimulate even more inflammation. And this is going to cause kind of a positive feedback loop. As it inflames, it causes more obstruction and more damage, which causes the recruitment of more immune cells. It's not cool. And as it inflames, it may rupture, and that rupturing would result in little blobs of fatty emboli. So instead of a blood clot moving around within the blood vessels, it's a chunk of fat moving around within the blood vessel. And as we look at these fatty emboli, a lot of times they'll move through the coronary artery to smaller and smaller branch arteries and arterioles and get stuck in one of them and restrict blood flow to a section of cardiac muscle tissue. This is going to cause coronary artery spasms. These coronary artery spasms are where the coronary arteries are contracting and relaxing, spasming due to the lack of secretion of nitric oxide, which is a vasodilator. So this spasm, this contraction, is not a good thing. It's going to restrict blood flow even more. This inflammation is also going to transform the atheroma into a completely hardened and complicated plaque. Once it's been hardened, it's typically going to be hardened by absorbing calcium ions. This is the same thing that happens with the plaques in your mouth. If you don't brush your teeth a lot, the tartar that's in your mouth will absorb calcium ions from your saliva and become a hardened plaque that needs to get scraped off when you go to the dentist, hopefully every 6 months. As we look at this plaque that's hardened, this is a primary cause of arteriosclerosis, the hardening of a blood vessel. And I remember as a student, I got these mixed up all the time. The hardening of a blood vessel is arteriosclerosis. And I'm going to back up the slide here. Two slides, actually. The buildup of lipids is atherosclerosis. Atherosclerosis leads to arteriosclerosis. So atherosclerosis is just the buildup of lipids or plaques within the blood vessel. And then once they've hardened, it becomes arteriosclerosis. Now, as we're looking at coronary artery disease, a very big risk factor for it is an elevated or excessively high level of low-density lipoproteins, LDLs. LDLs are referred to as the bad cholesterol for anyone who's ever had their cholesterol tested. HDLs, high-density lipoproteins, are the good cholesterols. And when we look at LDLs, LDLs are a droplet of cholesterol, but since cholesterol and fats and fatty acids and phospholipids, all these lipids are hydrophobic and don't mix with water well, they need to be coated by an antipathic protein that allows for them to be dissolved within the bloodstream. And as these LDLs, these blobs of lipids and proteins are moving around within the bloodstream, they are going to be able to build up on the walls of our arteries. And as they build up on the walls of our arteries, because we have receptors for them within our arterial cells, we'll accumulate excessive amounts of cholesterol. And this is going to contribute to an increased amount of atherosclerosis. So, what can you do? What are some of the risk factors? Some of them are behavioral, some of them are just unavoidable. So, unavoidable risk factors include your genetics. Your genetics determine more than anything else what your cholesterol levels are going to be. It's the single biggest factor. Generally speaking, if you look at your ancestors' traditional diet will typically indicate whether or not you're going to have a elevated risk or not. So I'm thinking of Germans and Swiss. Traditionally, German and Swiss people ate lots of really high-fat food, and consequently, individuals that had bad genetics for coronary artery disease within those people groups were selected against. So then, after generations of selecting for Germans and Swiss individuals that had better genetics to handle coronary artery disease and incredibly high-fat diets, we find that those individuals are more with those ethnic group or ethnic ancestries are more likely to have good genetics. I'm thinking of my grandpa Eddie, who came on the boat over from Switzerland. He ate bacon and eggs and cheese with extra butter on top every day for breakfast, and he had some of the best blood cholesterol levels ever. And consequently, since I'm only 2 generations removed from him, I'm still benefiting from some of his genetics. And I'm thinking of other people groups that traditionally didn't have super high fat diets, but instead had high carbohydrate diets. And those people groups, I'm thinking particularly right now of individuals of African descent. They, generally speaking, don't have the best genetics to fight against coronary artery disease. Their heredity causes them to have elevated, or causes them to be more likely to have elevated low density lipoproteins in their blood. And what we find is that among individuals of African descent, there is a higher than average rate of coronary artery disease. Something else that you can't really help is your age, your biological age. As you get older, it's more likely that there'll be problems. And another one is being a male, your sex. If you are a male, so you have that XY chromosome, or at least an SRY region in your genome, being male is another elevated risk factor for coronary artery disease that you just can't help. And then when we look at preventable risk factors, these are things that we can help. So being overweight increases your risk, smoking increases your risk, being a couch potato increases your risk, being stressed out all the time increases the risk of coronary artery disease. As you're activating your sympathetic nervous system, you're going to dump extra lipids into your bloodstream for anticipation of that exercise. So take it from me, there's good medical advice. Relaxing, chilling out is good for you, metabolically speaking. There's even an ancient Middle Eastern proverb that says that bitterness rots the bones. And I love that old proverb, bitterness rots your bones. The idea behind this is that people that are generally really disagreeable are going to have more health problems than people who are more agreeable and chillax, because of that constant activation of the sympathetic nervous system causing the stress response in their body. So what can you do to treat coronary artery disease? Oh, I forgot to mention diet. Your diet does determine your LDL or cholesterol concentrations, but it's not as significant as your heredity. But diet does play a role. To treat coronary artery disease, you can have a coronary bypass surgery, where if you have your blood vessel and there's a plaque built up in it, the surgeons can stitch in another blood vessel harvested from somewhere else in your body and give the blood an alternative flow to go around the plaque. It's kind of like a bypass. Typically, the blood vessel that's harvested is from the great saphenous vein of the leg or some of those smaller thoracic arteries. We also can use balloon or laser angioplasty. And angioplasty, in this context, is when we're going to remove the plaque from within the blood vessel. So if we use a laser-based approach, that laser is going to ablate, and I love this term, ablate. It's going to zap the plaque and break it up into small constituent molecules or particles. And if we use the balloon therapy, that balloon therapy is going to insert a balloon, you fill up the balloon, and then you pull the balloon back out. And it scrapes the plaque with it. That balloon therapy is actually used by plumbers. If you go to the hardware store, you can buy a balloon that you can shove in your drain pipes in your house, and then you fill, and once you get it in your drain line, you turn on your garden hose. The garden hose fills up the balloon, and you drag it back out of your drain line, and it scrapes all the slime with it so that your drains are unclogged. It's really gross. The other method is a stent. And when we think of a stent is shown down here. And this stent is the insertion of a mesh that holds the artery open. It forces the lumen open so that we can have an increased rate of blood flow. That's all we have for this recording. If you have any questions or comments, please feel free to post them on the class discussion board or to shoot me an email. And as always, happy studies.